Hey guys, welcome back to the third video in our campus placement dataset playlist. In the previous video, we understood what outliers are and we understood how to get rid of those outliers. We understood what a box plot is and how to use the concept of whiskers and how to use the concept of quartiles to get rid of those outliers. Right. So in today's video, we're going to talk about another very important concept, that is data visualization. So let's get started. Okay, so data visualization is basically used to get better insights out of our data using graphical methods, right? So let's start with one of the most basic graphs, that is the count plot. Okay, so let's start by defining a figure size just like before, and after that we'll create a subplot just like before, right? So we're creating a 2x3 matrix and we're pointing at the first graph in the matrix, right? And after that we'll be using the SNS library, the C1 library that we imported in the beginning of our project, and we'll be using the sns.countplot right now. So equal to sns.countplot, and we'll be having the x-axis as gender and the data as placement underscore filtered, right? So yeah, let's execute that. So we get a basic count plot. So let me just print all the different count plots that I want to print, and after that we'll draw some inferences from these. So I'll see you in a second. Okay guys, so as we can see from all of these different graphs that we have, the first one we have created of gender, then HSC score, then the degree, then the specialization, work experience, status, right? All of that we can see in these x-axes. So what are the different inferences that we can make from these graphs? The inference that we can make from the first graph is that we have more male candidates than female, right? From the second graph, we can see that we have candidates who did commerce as their HSC course as well as undergrad, right? So in the third graph, we can see that the science background candidates are the second highest, right? The commerce and management are the highest in both of these cases, right? So from the fourth graph, we can see that the marketing and finance people are more. After that, from the fifth graph, we can see that the people with no work experience are more, and from the sixth graph we can see that there are a lot more students that are placed than that are not placed, right? So just from these graphs we can easily make these inferences. Okay, so the second visualization that we're going to take a look at is the dist plot. So a dist plot or a distribution plot depicts the variation in the data distribution, right? So we're going to use the Seaborn dist plot. For that we're going to use the placement placed. We're going to create a new data structure. Let's call it placement underscore placed, right? And in this data structure we're going to filter all those people, all those candidates who have been placed in a company, right? We're going to not have any one of those who have not been placed in a company in this data set, right? So let's filter those people, placement underscore filtered. Okay, so what we've done over here is we've created a new data structure and we've filtered all those people who have been placed, right? So for that the condition will be the placement filter dot salary is not equal to 0, That means if the salary is not zero, that means the person is placed. The salary is zero only for those people who haven't been placed, right? So we're passing this filter inside the older data structure, and we're creating a new data structure, and finally we're creating a dist plot, a distribution plot for that, right? And as we can see, this distribution is equivalent to a normal distribution. If any one of you has studied statistics before, we can easily say that this distribution is equivalent to a normal distribution. And there are many candidates who have had a package between 2 lakhs to 4 lakhs rupees per year, and there are really few candidates who have even reached 10 lakh rupees per year as well, right? So the average salary is between 2 lakh and 3 lakh, around 3 lakh rupees is the average salary. So all these inferences can be deduced from a single graph. So let's move ahead. Okay, so for the final visualization in our mini project, we're going to take a look at a Violin plot, and we're going to check if there is any gender bias while offering the salary, right? So for that, we're going to import Plotly Express. So if this certain line does not work in your code, it's probably because you haven't installed the Plotly Express library. So you can go to your Anaconda prompt and you can pip install the Plotly Express, and then this should work fine, right? So we're gonna create a Violin plot. So the command is px.violin. Right. So as we can see from these graphs, the blue color represents a male and the red color represents a female. Right. So we have categorized this on the basis of specialization on the x-axis. So MK and HR means marketing and human resources, and MK and FN means marketing and finance. Right. So these are the two job specializations. So as we can see in both the cases, the let's first take a look at the number of dots, right? The number of dots in both the cases, in marketing and human resources and marketing and finances, is greater in the case of blue, right? There are more dots in the blue color than there are in the red color. That's because that defines that there are more male candidates that are selected for the job than there are female candidates, right? The same can be said about marketing and finance as well. There are more male candidates than there are female candidates, right? So that's one of the inferences that can be made from this Violin plot. Another one can be that the highest packages that are given are to male candidates, right? The highest female package that we can see is around here, that is around 400k, that is around 4 lakhs, right? But the highest male package goes at around 940k, that is around 10 lakhs. So this is another inference that we can make from these Violin plots. So what these Violin plots basically represent is that if we turn these graphs by 90 degree to the right, so they're gonna basically depict the distribution of our curve. So they basically depict the normal distribution. So we're not gonna go into the depth of these plots, we're just gonna see how to visualize these plots, right? So these are some of the inferences that we got are there, that more males were placed as compared to females, and the higher packages were given to males as compared to females. So there was indeed a gender bias while selecting the students for jobs after completing their MBA. Right. So after this, we're done with the visualizations. There's obviously a lot more things that you can do, but for the sake of this video and the sake of this project, we're going to stop right here because there's no end to the different types of visualizations that we can do. So after that, let's move ahead with the next obstacle that we're facing, that is encoding. Right. Okay, so that's it for the third video, guys. I hope you enjoyed this video, and I hope you enjoyed the different types of data visualizations and different inferences that we made from these visualizations. In the next video, we're gonna talk about the final step in the data pre-processing process, that is called encoding, right? So I'll see you in the next video. Thanks for watching.